Ever tried predicting the weather? It's notoriously tricky. Tiny changes in temperature or pressure can spiral into completely different outcomes. That's chaos in action. But what if we could build AI that understands these unpredictable systems? Today, we're diving into a groundbreaking model called Panda, which is rewriting the rules of forecasting chaotic dynamics. Chaotic systems, like weather, brain activity, or even stock markets, are super sensitive. A teeny error in your data. It blows up over time, making long-term predictions nearly impossible. Traditional AI models tackle this by either focusing on one system at a time or training on massive datasets with little structure. But here's the catch. They're like learning to drive by only practicing on one road. What if you need to navigate a whole city? That's where Panda steps in. Developed by researchers at UT Austin, this model isn't just another AI. It's a universal forecast tool trained on 20,000 synthetic chaotic systems. How did they create that dataset? Think of it like a digital evolutionary experiment. They started with known chaotic systems, like the famous Lorentz attractor, which models weather patterns, and used an algorithm to mutate and recombine them. It's like genetic engineering, but for math equations. Here's the magic. Panda wasn't just trained on simple equations. It learned from a vast array of chaotic systems, developing a kind of intuition for their behavior. Even though it only saw low-dimensional equations, think 2D or 3D models, it somehow figured out how to predict high-dimensional ones, like complex fluid flows or neural activity, without retraining. It's like teaching a kid to ride a bike, then expecting them to pilot a spaceship. The results? Panda can forecast unseen systems with zero prior exposure, what's called zero-shot learning. Imagine training a model on a bunch of pendulums, then asking it to predict a double pendulum's motion. It's not just guessing, it's spotting hidden patterns in the chaos. And here's the kicker. The more chaotic systems it's exposed to, the better it gets. The researchers even discovered a new neural scaling law, linking performance to the diversity of systems it's trained on. But how does it work? Panda uses a clever architecture with attention mechanisms that focus on the most critical parts of data, like a detective zeroing in on clues. It also employs dynamic mode decomposition, a math trick that breaks down complex systems into simpler, repeating patterns. Together, these tools let Panda decode chaos in ways traditional models can't. Here's where things get really wild. Panda doesn't just memorize patterns, it understands the structure of chaos. Think of it like a chef who learns to cook by studying recipes from every cuisine, then whipping up a dish from a completely new culture. The model's attention maps reveal it's not just looking at the immediate past. It's picking up on hidden relationships between variables, like how a shift in wind speed might influence temperature hours later. The researchers tested Panda on systems it had never seen before, like fluid dynamics simulations and neural activity patterns. And it crushed them. Even when faced with rare events, like a flame suddenly splitting into two or a vortex pinching off, it adapted in real time. This isn't just a technical achievement, it's a paradigm shift. By training on synthetic chaos, Panda unlocks a new frontier in AI-driven science, from climate modeling to neuroscience. So what's next? If Panda can decode chaos, what other mysteries will it unravel? The answer lies in the data, and the ingenuity of researchers pushing AI beyond its limits. Stay curious and keep exploring the edge of the unknown.